Hi there and welcome. Today I'll show you how to build a multi-language text-to-speech reader app that runs locally on your computer. This is what we'll be building. Have a listen.
In the tranquil pond, Philly and Flicker darted through the water, their scales shimmering like jewels.
And now for an Italian voice.
L'aria era fresca e soleggiata, il cielo era azzurro con alcune nuvole bianche che si erano fatte, come se volessero unirsi al divertimento.
This is a solution for anyone wanting to integrate a reader app into their own projects. This is a Python-based application that uses Flask for the server-side logic and data exchange between the back-end and front-end. Flask is extremely useful for the maximum control of the front-end and for requesting data without having to refresh the browser or restart the Python app. Hyper is a text-to-speech engine used together with eSpeakNG to convert text-to-speech ready for playback. Simple audio is used for the actual playback of sound. Firstly, we'll set up our Python environment and install the Python requirements for the project. Next, we'll create the project folder and file structure. Then, we'll download some voices. We'll start copying over code, and with each step, we'll test the app in the browser. Right at the end, we'll explore the source of the voice settings a little more. We'll be inserting code to 4 files: app.py, INDEX.HTML, READER.JS and READER.CSS. There's a moderate amount of code, so I won't be typing any code in this video, other than making voice setting adjustments. Instead, I'll be following the guide from my website clemtech.xyz. I'll present the code and explain the important bits. I'll build the project in front of you and show you a working reader solution for you to take away for your own projects. I'm developing on an Intel i7 machine with 32 GB of RAM and 12 GB of GPU, running Windows 11 Pro. I'm using Python version 3.11. Use this Python version or later for the project. I'm using PowerShell for my command line utility and the Google Chrome browser with English and Italian dictionaries installed and cache disabled. I'm using Visual Studio Code for my code editor with indentation set to 4 spaces and character encoding set to UTF-8. Let's go ahead and create the project folder and Python environment. I'm naming my project Piper. Using PowerShell, create the folder. Next, create the Python environment. And finally, activate the environment. Installing the Python requirements. Have your Python environment activated and ready. Before we start, let's see what Python libraries we have so later we can tell which additional support libraries get installed using the command piplist. Let's go ahead and install Flask, Flask WTF and requests. Let's inspect the library versions. These are the latest builds and we'll be proceeding with these. Install Piper TTS and check the version. Finally, install Simple Audio and also check the version. Simple Audio requires Microsoft Visual C++ build tools to install correctly. If you are experiencing errors, look for the suggested solution within the error message. Let's create the project structure. Create the following folders and files. We'll create a working folder called User Data, and note, the folder's static and templates are required specifically by Flask. Flask searches for an index.html file in the templates folder. Create the files to house the code. And finally, create the folder used to house the voice models. There are multiple places where you can download Piper voices. I will be downloading the public accessible voices from Hugging Face. Use the URL in the slide or click the link from my website. 2 files are required for each voice: an Open Neural Network Exchange file and a JSON supporting metadata file. I will be adding the English voice Kathleen and the Italian voice Paola. The ONNX files for both voices are around 60 gigabytes, and this size is ideal to run from a desktop setup. Later, we'll play around with the voice settings such as a length scale, noise scale, and noise W scale. I mostly use the voice Kathleen, and therefore I hard-coded the voice settings to my preferences for Kathleen's voice. Once you've downloaded at least 2 voices, move them to the Voices folder. Before leaving Hugging Face, it's worth having a quick read of the license covering the voice files. Let's add the code to app.py. Have your code editor ready. Copy the code from my website and paste it into app.py. Save the file. In a moment, we'll run the app and inspect the code, but before that, change the app version to your project name and modify the pipe of voices list to only include the voices that you downloaded earlier. Be sure to retain the line numbering. Notice at the bottom of the file, this code starts the web server and launches the Flask development server. Save your work. In PowerShell, have your Python environment activated and ready. Run app.py and check for errors. Run the app using the following command, but also ensuring that you use your version of Python and project file path. There are no errors with the code so far. Errors at this stage will likely be due to missing libraries or incorrect indentation. Later you'll be visiting this URL in your browser, but right now there is nothing to see. Let's move away from the code editor and into the code presentation. These are the Python requirements for this project. Request provides access to incoming HTTP request data from a client, and JSONify handles serialization. Creates the Flask instance and sets up a private key for the application. Set a strong secret key for production use. This function returns a list of pipe of voices used to populate a Flask select field. This sets up a Flask form in preparation to render data to the browser, where it is processed in the INDEX.HTML file. The form contains a select field, or better known as a drop-down, containing the pipe of voices. Please note, these highlighted characters on line 43 were included in error. This is what the line should look like. While the characters won't have any noticeable effect on the app, you are encouraged to remove them. This is the Flask route to the root of the website. This index function is mapped to the root of the website. Here, we're rendering the app version and form data to the file INDEX.HTML, where it will become accessible for processing by Ginger2 and JavaScript. This sets up the Flask route for the reader that maps to the function reader for processing post requests. Reader action is used to stop the audio when the user clicks the Stop Reader button. As you will see later, when you click the Stop Reader button, the reader continues reading to the end of the chunk, usually to the end of a sentence, before it begins to process the stop request. SA.StopAll is a method from Simple Audio used to immediately stop all playing audio, but unfortunately it does not work with this implementation with Flask. Implementing reader action is a workaround that is able to stop all instances of playing audio at once, and works with this implementation with Flask. Here's a process flow of the reader function. Here's the first process flow that produces a JavaScript error if by chance there is no data to process. In this second process flow, there is data to process and the reader reads until all data chunks are read. Once there is nothing left to read, the reader stops. This third process flow shows the reader currently reading and an action request to stop reading has just come from the user. Since the reader action is queried before continuing to process chunks, the user request is satisfied and the reader stops. In the cases where you start multiple instances of the reader, just one click of the button Stop Reader will result in stopping all instances. This is due to declaring reader action as a global variable. Here we receive data from the front end and we expect some data. If there isn't any data to process, an error is sent back to the front end. If we have some data, this is assigned to variables, user message and user options. User message does not hold any data in this project. I keep it alongside user options as a matching pair for all my asynchronous functions. Here we assign values from user options to variables. Action will only ever hold values read aloud or stop. We extract the values for the Piper model and text to read. If the action condition is satisfied, we continue. We set reader action to playing. Here we assign values to variables for the voice. This is where we provide each voice with their unique settings to make them sound and perform to our liking. The voice settings are hard-coded in this project, but they can be preloaded, either hard-coded, coming from the voice's JSON metadata file, or coming dynamically from the front end. The comments provide a brief explanation of the settings. Here we load the voice and assign audio-specific values that will be passed to the player, simple audio. The sample rate value is extracted from the voice's JSON file. Here's an excerpt of the JSON file from the voice Kathleen. Here's the sample rate. Also notice the default value for length scale, noise scale, and noise W scale. Later, we'll add some code to extract these values and apply them directly. This is the for loop where the magic happens. Here, we synthesize text into audio object chunks and begin to process them. Here we extract the raw audio data from a chunk object. This is the point at which audio playback is initiated via simple audio. Before continuing to process more chunks, a check is made to see if the user has made a stop reader request. If they have, we break out of the for loop and the reader process stops. The audio playback, however, continues until the audio at hand has finished playing. It's at this line where execution is paused until the audio playback initiated by the play object has finished. Once finished, the next chunk is processed. If there are no more chunks to process, the reader stops. We arrive here once there are no more chunks to process, or if we broke out of the for loop. Sets the server response to the value stopped stopping if the condition is satisfied, and as you can see, the condition is always satisfied given the assignment of reader action on line 137. Here we return the JSON server response back to the front end. If audio chunks were processed in their entirety, we would expect playback to end and then the server response sent. If we force the reader to stop, we would expect the playback to continue after the server response has been returned.
In the tranquil pond. In the tranquil pond, Finley and Flicker darted through the water, their scales shimmering like jewels. They chased each other around the lily pads, laughing and splashing in delight.
Returns the JSON response for any errors that may have occurred. That concludes the code for app.py. Let's add code to index.html. Have your code editor ready and index.html file selected. Copy the code from my website and paste it into index.html, then save the file. In a moment, we'll inspect the code, but first, let's run the app in our browser. Ensure that you have app.py running in PowerShell. Have your favorite browser ready and enter the URL http://127.0.0.1:5002. We'll add the styling a little later, but hopefully you see something similar in your browser. Let's move away from the code editor and into the code presentation. We use Ginger2 syntax to extract the version data. Here, we include Reader.JS and Reader.CSS into our project. Both of these files are currently empty. We use Ginger2 syntax to extract data for the label and select field. These are the hard-coded buttons. This code builds the reader status section. This is the text area that currently holds our sample text. That concludes the code for index.html. Let's add the CSS styles. Have your code editor ready and the Reader.CSS file selected. Copy the code from my website and paste it into Reader.CSS. This is the style for the reader status spinner. You can change its color here. Save the file and let's run the app in the browser. There's no functionality right now, but hopefully you see something similar in your browser. Let's add the JavaScript code. This is the last of the code and it will give life to the reader. Have your code editor ready and the Reader.js file selected. Copy the code from my website and paste it into Reader.js. Save the file. In a moment, we'll run the app in the browser and then inspect the code. But first, ensure that app.py is running in PowerShell. Also bring up the browser's development tools to check for JavaScript errors. Press Ctrl+Shift+I on your keyboard to bring up the tools and select the Console tab. Now refresh the browser and have a play.
In the tranquil pond. Flicking back and forth.
Ciao, come sta andando? Spero che tu stia godendo della presentazione.
Everything works fine so far, and hopefully everything works for you too. Let's begin with the code presentation for Reader.JS. This function kicks in after all the DOM elements are loaded. Here we populate the text area with some sample text. This is the asynchronous function for the reader's front end. The reader process is initiated when this function is called. Here we call the function that sets the reader status and starts the spinner animation. Here we assign data to send to app.py. This is how app.py receives the data. This code sends an asynchronous request to the Flask reader route in app.py and waits for a response. A message and options data is sent along with the request. While the message data remains empty, the options data contains a button action, the selected Piper voice and text to read. Here we process the return data from app.py. The data that comes back is used to set the reader status. This code handles any errors. As an example, JavaScript will throw a 500 error if a Piper voice cannot be found. This is the function that sets the reader status text and spinner animation. This function returns a selected value from the voices selection box. This function processes the button clicks. Firstly, we process the action to stop the reader. If the condition is satisfied, the call is made to the function sendReaderAction, which triggers the stop reader process. If we reach here, a button other than stop reader was clicked. Here we get a reference to the text area that holds all the text. Here we declare a variable to hold the actual text to read. Given the action, a call is made to the function getSelectedText, passing a reference to the text area object and the requested text portion to construct. In the case of read aloud, the entire text area text is assigned directly. Then finally, we make the call to send reader action, passing the action read aloud and the actual text to read. This triggers the start of the reading process. This is the function that constructs the actual text to read. Here we process a selection of text starting from the cursor position, a sentence marked from the cursor position to the first occurrence of a full stop, question mark or exclamation mark, or a paragraph marked from the cursor position to the beginning of a new line. For read sentence and read paragraph, it didn't seem necessary to construct the text to read from the beginning of the sentence or paragraph. That concludes the code for Reader.js. Let's revisit app.py, in particular the voice settings. We'll replace the hard-coded values with new code that loads the settings directly from the voice's JSON file. Here are the settings for the voice Kathleen as seen in the JSON file. We'll load the values from this file. Comment out the hard-coded section. Insert the updated code starting on line 116 and take a moment to inspect the code. Here, we load the settings the same way we loaded the sample rate. Let's run the app in the browser.
In the tranquil pond, Finley and Flicker darted through the water.
The default values makes the voice read slow. Let's update the values in the JSON file to my preferred values for the Kathleen voice. Once updated, run the app in the browser.
In the tranquil pond, Finley and Flicker darted through the water.
And there you have it. You can set your preferred voice settings directly in the voice's JSON file. One final note, our version of Piper will only read a value noise W scale. It looks like Piper falls back to looking for noise W in any case. Research suggests to update the voice JSON file with noise W scale. This is the end of the presentation. I hope that you had success implementing the reader solution. My final words are spoken by the reader we just created. See you next time.
The emergence of AI as a technological force is poised to revolutionize the way we think. What truly excites me is the accessibility and inclusivity of this innovation, thanks in large part to its support from the open source community. The idea that something so complex and cutting-edge can be developed, shared, and built upon by people from all over the globe resonates deeply with me. For me, it's not just about the potential applications or outcomes of AI, but about the very idea of people coming together to shape their own future.